Okay, let's do the first part of this problem. 15.5 liters of N2 reacts at STP to make 28 liters of ammonia. Yeah, so it already gave us how much was actually done. So if we were in a lab right now, it's just telling us, hey, we had 15.5 liters of N2 and we got 28 liters of ammonia. So we know the actual lead. That's what shows up in a lab. But we don't always do things correctly in a lab. So we need to find out how much is the theoretical yield. So here's the word theoretical yield. What this means is what is the most we can make mathematically. Now, we have one given right here. And because this is the one it's giving us, we can assume that somebody's already done this and said, all right, we know that N2 is the limiting reactant, right? So we're going to assume that's the limiting reactant. So that's what we're going to work with. So using N2 as a limiting reactant, we're not even going to pay attention to this for now, just to clear my brain space. So then I can start working. So always take my given liters N2 and put it over 1. All right, so now I know I'm starting in liters. That's the unit of volume. And what am I trying to end in? To make 28 liters. Cool. So I'm trying to see how much I would get in volume as well. So I've got to go from here to here to here. The great thing about this is it tells us a number. We don't have to do that annoying math with grams. So now we actually just have to copy down exactly what the mole map tells us. So first thing it tells us is put 1 mole of what you start with, which is N2, over, let's say 22.4 liters. See my units cancel out. That's a good way to check to see if I'm setting up correctly. All right, check. So now I'm here. Okay, right, 1 mole, I'm in moles. Now I do my mole ratio. So I'm going to write down, it says question mark. Anytime you see a question mark, you're going to have to figure that out. A mole Y, so the thing I'm looking for, what am I looking for? Ammonia over the moles of what we started with, which is N2. Okay, so now I have to go, where am I going to find these numbers? From my balanced equation. Where's my balanced equation? It'll look like this. So there's no number in front of the N. I'm going to put 1. There's a 2 in front of the NH3, so I'm going to put a 2. Sweet. So I've done this, so now I'm here. All right, one last step. 22.4, I'm just copying down what it tells me. Again, I'm going to just back up one step, see how my units cancel. Mole N2, mole N2. Great way to see if you're doing it correctly. So now, let's see, 22.4. I'm just copying this down here. Liters of, what's it asking me for? Oh, of the thing I now have, NH3. H3 over 1 mole of NH3. Alright, if this part's proper, this and this should cancel. Yep, moles and moles. So now I'm going to do some math. And while I'm doing this math, something to keep in mind is that the number I get should be bigger than 28, right? Because you can't make more than what's theoretically possible. So if I get a number that's super, 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 super small, that either means I did my math poorly or whoever did this lab really messed it up. But for now, I'm just going to type in my numbers, 15.5 times 1 times 2 times 22.4. That's going to equal what? 672. Ooh, that's a nice and neat number. 672. All right, now let me do the bottom. Sweet, don't even need to because 1 times 22.4 times 1 times 1 is going to be 22.4. So I am predicting that this number is going to be bigger than 28. In the real world, that's generally how it works, but we shall see. Divided by 22.4. 30. 30, what, if you forget? What's the unit that didn't cancel out? The very last one on the top, liters. of NH3. So now I have my theoretical yield. My theoretical yield is 30 liters of NH3. So I can go and do this. What is the percent yield of ammonia? We would have to show all this work, but it is going to be 30 liters NH3. I'm not going to, little pro tip. It's a good way to not have to type those things out. Great.